Hello everyone, welcome to iTunes Academy. Here is our first course about algebra. So, what's meant by algebra? Algebra is study of variables and rules to manipulate these variables, which published first by algorithm. Here, what's meant by variable? If I write that x, y, and z, what's meant by that? This is just letters, okay? But if I write that just letters. But if I write that x plus y equal to z, okay? Now something changed. What changed? Now I can say x and y is the inputs of any system, and z is the output. So now x and y are variables, which represent an unknown number. Okay, so let me write that. If I write that x minus y equal to 1, okay, so okay, and x plus y equal to 3. Now I have two relations between x and y, so I can say that this is first relation, okay, second relation between x and y. X minus 1 minus y is now expression of input, and 1 is the output. Okay, this is linear equation. Also, this is linear equation. If I represent that in the x and y axis, okay, so first equation by this line, okay, so second equation by this line. Okay, I can say this point is the intersection between these lines. Now, just write that 2, 1, okay, the intersection between these lines, okay, okay. So, when x equal to 2 and y equal to 1 in both lines or both equations, now I can say these equations are simultaneous, which I can solve it at the same time. Okay, here is in our course we will discuss 6 cases of. Now let me clear that. Okay, and that. Okay, as we say, we have 6 cases. Okay, in this first chapter of Simultaneous equation. First case here is two linear equations, just like that. Let me write that. If we have x minus 2y equal to 3, okay, and 3x plus y equal to 6, linear equation, I have three methods of solution of this equation. Okay, one is by substitution, by one variable into another. Okay, the second is elimination, by eliminate one of these two variables in one of this equation. And third is by graphical solution. I can draw this line and get the intersection point between them. Okay, we will deal in this course with substitution and elimination and graphical later on in other course. Okay, so let's start. I have to solve these two equations together to get the intersection point between these lines. That's our solution. Okay, let's start by substitution. I have equation 1 and 2. Let's get it. Okay. By substitution, I will substitute by one of these variables in one equation into another. So I can write that x from 1, x equal to 3 plus 2. Okay, and sub into 2. So let's solve it. So 3 plus 2y plus y equal to 6. Okay, so let's do that. 9 plus 6y plus y equal to 6. If I solve that in y, I will obtain that y equal to 1. Okay, now back substitution to get x in each of these equations. So into 1, I can get that x minus 2, 1 equal to 3. So x from here equals to 5. So I have now solution is x equal to 5, y equal to 1. Okay, this by substitution. Now we will discuss elimination. Let's let's clear that, close that. Okay, okay, that, okay, okay. By elimination, okay, I will eliminate one of these variables from and combine two equations to form new equation in one variable. Okay, so I can multiply this by 2. Okay, so let's start now. 2 3x plus 2y, okay, equal to 32. Okay, now let's write that plus 2y equal to 32. Now I have new equation, call it 3. Okay, 3 and 1. I have here minus 2 and I have here positive 2. So I can eliminate that by add. So add 1, 2, 3. Okay, now 7x plus 0 equal to 35. So from here x equal to 5. Now substitute in each of this equation 1 or 2 to get y. Now y equal to 1. Okay, this is the first case of simultaneous equation. Now let's start with the second case here, linear equation with quadratic equation. If I write that x 5x plus y equal to 7, okay, and the 4x plus 3y equal to 6, okay. Now as you see, two linear equation, but if I do that now, I have 4x squared plus 3y squared equal to 16. So this is our first equation and this is second equation. So this is linear and this is quadratic equation. So how I can solve this equation together? By by elimination, not valid here. I can't eliminate one of these because in the second equation x and y in the square form. Okay, so the method here is substitution and already got. Okay, so let's start solve the solution by substitution. Okay, from the first equation I can write that y equal to 7 minus 5x. Okay, so in this form I can substitute by y in the second equation. So let's do that. 4x squared plus 3, 7 minus 5x, okay, equal to 6. After substitution by y in the second equation, we can rearrange that, okay? So let's write that 4x squared plus 3 into this bracket square. So I can write that 49 with square of 7 minus 70x, which 7 by 5 square, okay, plus 25x square equal to 6. Okay, so let's Let's multiply this 3 in this bracket. Okay, so 4x squared plus 147 minus 210x plus 75x squared equals to 6. Okay, let's rearrange that. So I can write that 79x squared minus 210x, okay, plus 131 equal to 0. Now I have equation in second order in x. So I can solve that in x. Okay, so I can write that x minus 1 and 79x minus 131. Okay, now I have x equal to 1 or and x equal to 131 by 79. Okay, now I have x equal to 1 and x equal to 131 by 79. I can do that. I can back substitute to get y in the first equation. Okay, now if I substitute by x in the first equation, I can get that y equal to 2 if x equal to 1 and y equal to minus 102 by 79. So now I have 2 points, not single point of solution. Okay, this point, okay, and also this point. Okay, so okay, and that. Okay, our third case is two quadratic equation. Okay, if I write that 4x squared plus 9y squared equal to 72 and 3x squared minus 2y squared equal to 90. Now I have two quadratic equations in the second order. Okay, this first, second. Now I have two options. By substitution, if one of this equation is able to solve, so I can get x in terms of y, okay, but now I can't. So the only method I have here is elimination. Okay, so let's start solve this. Here I want to eliminate x or y. So the same we have to do is now I can multiply 3 by the first equation and 4 by second equation. Okay, so let's do that. Now 12x squared plus 27y squared equal to 260. Okay, the second by 4. Okay, so x squared minus 8y squared equal to 76. I have two equations now, but the coefficient of x squared are the same in both. Okay, so I can subtract one from another. So subtract one from two. Okay, so let's do that. Now I have minus 35y squared equal to minus 140. Now I can get that y squared equal to 4. So y here equal to positive or negative 2. Okay, now I can back substitute to get x from any of this equation. Okay, now from the first equation here, 4x squared plus, okay, 9 by 2 if y equal to 2, okay, equal to 70. Okay, now 4x squared equal to, this is, okay, so 4x squared equal to 36. So x squared equal to 9. Now you have that x equal to 3. Okay, and if I substitute by negative 2, I will obtain that same solution. Now I have 2 points of solution, 3, 2, okay, and minus 3 minus 2. But in fact, I don't have only these 2 points. I have 4 points. Okay, yeah. So I can write that I have also negative 3, 2, and 3, negative 2. So now I have 4 points of intersection. Okay, so let's clear that and move to the fourth case here. Okay, okay. Now let's move to our fourth case here. Two quadratic and one is homogeneous. Now, what's homogeneous equation? Homogeneous equation is just in this form. A, let me ax squared plus bxy plus cy squared equal to 0. So I can solve it in one of variables in terms of the other. Okay, let's take our example. If I have that x square minus 3xy plus 2y squared equal to 0 and 2x squared plus 3xy minus y squared equal to 30. So which one of this is the homogeneous equation? Yes, the first, okay, is the homogeneous equation. So I can solve it in terms of x or y. So I can write this in this form: x minus y into x minus 2y equal to 0. So x equal to y or x equal to 2y. Okay, now I have this 2. Okay, I can substitute by this in the second equation. Okay, so let's do that. First, x equal to y. So I can write that 2y squared plus 3y squared minus y squared equal to 30. Okay, so 4y squared equal to 30. Then y equal to plus or minus square root 13 by 4, and that is x2. Okay, now if I have x equal to 2y, okay, now 8y squared, substitute in this, 8y squared plus 6y squared minus y equal to 13. Now I have 13y squared equal to 30. Now y equal to plus or minus 1, and here x equal to plus or minus 2, because x equal to 2. Okay, so let's do that. Let's move to our 5 case. Let's clear that. Okay, okay, so our 5. Let's move to the first case here. Non-homogeneous equations. Okay, if I write that a x squared plus bxy plus cy squared equal to d. Now I have d. Okay, so this is not a homogeneous equation. Okay, if I have two of this equation, how I can solve it? Okay, just we will combine this equation to obtain homogeneous equation. Homogeneous equation. So d will be 0. Okay, this example here, 3x squared sorry, just okay. 3x squared plus 8y squared equal to 140. Okay, and 5x squared plus 8xy equal to 84. This first, second. What I can do here to eliminate this term, the d term will be 0. So I will add or subtract two equations to eliminate this term. Okay, so let's multiply this equation by 3 and this by 5. Okay, let's rewrite that. So 9x squared plus 24y squared equal to 420. Now 225x squared plus 40xy equal to 420. So I can now subtract one from another. Okay, let's do that. Now I have 16x squared. Okay, just make that plus 40xy plus minus 24y squared equal to 0. Now I have homogeneous equation, so I can solve it in x or y in terms of the other variable. Okay, so I can do that. Just simplify that. Now I have 2x squared plus 5xy minus 3y squared equal to 0. Just divide by 8. Okay, now I have that 2x minus y and x plus 3y equal to 0. Now x equal to half y or x equal to minus 3y. Now I can substitute of x by x or y in terms of another in one of these equations. So let's do that. Let's substitute by x, okay, in the first equation. Now write that here 3i squared plus 8y squared equal to 4. Okay, so 3 by 4y squared plus 8y squared equal to, okay, now I have that. If I simplify that, I will get that. I will get that. Y now just multiply by 4. Now by 4, so that will be 35y squared equal to by 4. That this that equals to 60. Now y squared equal to 60. y equal to plus or minus 4. So that when x equal to half y. Now x equal to plus or minus 2. Okay, let's do the same thing with this case. Okay, let's do that. Just clear that. Okay, now I have 3 x squared just minus 3y squared plus 8y squared equal to 4. Okay, now this will be 27y squared plus square equal to, okay, now 35 y squared equal to, okay, y here 4 equal to y squared equal 4. So now just type it, y equal to plus or minus 2, but x equal to minus 3y. Okay, so x equal to minus 4 plus 6. Now I have this solution, this and this. So what I did here, just combine this equation together, okay, to get one equation, this homogeneous equation, just solve it in one variable in terms of another. I get x equal to half y and x equal to minus 3y. Okay, okay. Now let's move to the last case. Let me clear that. All of that. So, yes. Let's move to our last case. Two symmetric quadratic equation. What's symmetric equation? If I write that 4x squared plus 4y squared plus 3xy plus 2x or 2y 2x equal to 20. Now, if I interchange between y and x, y and x, y and x, nothing will change in this equation. So I can call it symmetric equation. Okay. Now, how can I solve it? If I have, for example, these two equations. Okay, these two equations, x squared plus y squared plus 3x plus 3y equal to 8 and xy plus 4x plus 4y equal to 2. What I can do here, just first step in solution here to substitute by x equal to u minus plus v or minus y equal to u minus v. But why I substitute with that? Because if I take these values and put it here, nothing will change. Okay, now rewrite that in these forms. Okay, now u plus v square plus u minus v square plus 3 u plus v 3 u minus v equal to 8. First equation. Now u plus v u minus v plus 4 u plus v plus 4 u minus v equal to 2. Just simplify this. I can obtain that from the first equation square plus 2v square plus 6u equal to 8. Okay, and second equation can be simplified to that u square minus v square plus 8u equal to 2. Now I have this equation, non-homogeneous equation, and x in u and v. So I can eliminate this term. So I can obtain an equation in just u, okay, by 2. So I can get that 4u square plus 22u minus 12 equal to 0. Okay, now just solve it for u. Okay, 2u minus 1 and u minus 6 equal to 0. Now I have that u equal to half or u equal to negative 6. Okay, if u equal to half. Okay, in this equation v square equal to u square plus 8u minus 2. So if u equal to 1 by half, I can write that plus 4 minus 2. So u, so v equal to 3 by 2 square. Okay, now v equal to plus or minus 3 by 2. Okay, if u equal to half. Now, but if y, just here that, all of that. Now u equal to minus 6. Okay, just v square equal to u square plus 8u minus 2. V square will be negative 40. Okay, if I substitute with that. Okay, now v is plus or minus square root of negative 40. This v equal to plus or minus I. I obtain here imaginary number. Okay, so thus rearrange that to get x, our x and y. Okay, now u equal to half v equal to plus or minus 3 pi. Now x f, okay, f v equal to plus 3 pi. Okay, now x equal to u plus v equal to half plus 3 pi half equal to 2, and y equal to z, so y equal to negative 1. Okay, f b equal to negative 3 pi 2. Now x equal to u plus v equal to minus, okay, minus 1. Y equal to 2. Okay, f u equal to negative 6. Okay, v equal to plus or minus I square root of 14. Just write that x will be negative 6 plus or minus I square root of 14, and y equal to negative 6 minus or plus I square root of 14. Now I have this solution here, here, and here. I hope that's clear. Okay,